So this video is going to be focusing on the volume. Let me make sure I'm recording here. Okay, good. This video is going to be focusing on the volume of pyramids and cones. So last video we talked about prisms and cylinders. This one's going to focus on pyramids and cones. And just to make sure we note the difference, a pyramid is one base, a prism is two, and the corners of a pyramid base are connected to a single point, whereas the corners in a prism are connected to the other base. So this right here is a prism, and this right here would be a pyramid. They'd both be square, so this would be a square prism, this would be a square pyramid. But again, prism has one base, so base shape here, and then it's connected to a point on top, and the distance from the base to the point. So this distance right here is called the height. So the height is how far away the base is from the top point, and it's the perpendicular distance. So this would have to be perpendicular to the base. So usually it's drawn like that. So usually the height is given as a dotted line going from the middle of the base up to the point. Whereas in a prism, it has two bases. This is the base 1, and this up here would be base 2. So two base shapes connect at the corners, and again, the height in a prism is the distance from one base to the other. So the height is basically the line that connects the two bases, whereas in a pyramid, the height is a line that connects the top to the bottom base, because there is no second base to go to. So one way we attain new formulas in math a lot of times, in fact, this is kind of one of the ways that new formulas are discovered, is we figure out how they interact with old shapes or old formulas. So for example, we know that in a prism, we talked about last video, the volume is simply the area of the base times the height. So we wrote that at capital B times h. So if we had a triangle, we do 1/2 base times height. If we had a rectangle, we would do length times width. If we had a circle, we would do pi r squared. So capital B changes depending on what our base shape is, and then h being the height of the prism is how far away the two bases are. So again, the height in this case would be the distance from one base to the other, and if this was like A and this was B, then my capital B, my area here, would be A times B, because in a rectangle or a square, the area of the base is length times width. Now if it was a triangle, it'd be 1/2 A times B, because again, a triangle is half of a rectangle or a square, so it's 1/2 base times height. And again, base and height being the base and height of the triangle in that case. So again, for a prism, we just found the area of the bottom or top base and then multiplied it by however tall the prism was. So for a pyramid, since it's such a weird shape in terms of comparing it to a prism, we basically want to figure out how many pyramids does it take to fill a prism with equal base shapes and equal heights. So if we took a square pyramid that was like 2 by 2 and had a height of 3, and we took a square prism that was also 2 by 2 and it had a height of 3, how many pyramids would it take to fill up that prism? Because remember, volume deals with how much space is filling up the inside of an object, or how much space the inside of the object can contain. So think about a hollow pyramid and a hollow prism, filling the pyramid up with like water or something and pouring it into the prism. How many cupfuls or how many scoops of the pyramid would it take to fill up that prism? Now, usually I could show you this, but because I can't because of the situation we're in, there is a video on YouTube. If you go to this link here, which you can type into the URL, which if you don't know, but you're young, you should, is that little top bar there. So if you type it into that HTTP thing, if you type it in there, that will bring you to the video there. Or if you just go to YouTube and Google how many pyramids in a prism, it will pop up. That will take you to the video, and it will show you exactly how many pyramids it takes to fill up a prism. Now, not to spoil it, but again, just the videos are really there just to prove my point. It usually takes, or it doesn't usually, it always takes 3 pyramids full of water to fill one prism. So it takes 3 scoops of a pyramid to fill one prism. And this works for triangular, for rectangular, for circular, for pentagonal, for hexagonal. As long as the base shape's the same, and as long as the height's the same, 3 scoops of a pyramid will fill one prism. So you have 2 triangular shapes. You have a triangular pyramid of like 3 by 4 and a height of 5. You have a triangular prism, 3 by 4 and a height of 5. 3 pyramids to fill that one prism. Same for rectangles, again, squares, circles, everything. And again, the assumption is that the base shapes have to be the same. So this is a base shape of a square that's x by x. This is a base shape that's a square that's x by x. There should be an x there. And then the heights are the same. So this is a height of y. This is a height of y. So as long as the base shapes are congruent, and as long as the heights are congruent, this theorem holds, that 3 pyramids it takes to fill one prism. So with this knowledge, let's go ahead and revisit the prism formula. So the prism formula, remember, is base times height. Area base, I should say. So this is area of base. So the area of the base times the height. Since it takes 3 pyramids to fill one prism, that means a pyramid is only 1/3 as big, or 1/3 the volume of the equivalent prism. So if we want the volume of a pyramid, we simply take the volume of our prism and divide it by 3. So it's almost the exact same formula, luckily enough. It's just you're going to divide by 3 at the end, which is usually how I state it. If somebody asks me what's the volume of a pyramid, I say treat it like a prism, find the area of the base times the height, and then divide it by 3 at the end. So a pyramid is always divided by 3 at the end, because again, if everything else is equal, a pyramid will always be 3 times smaller than a prism, or 1/3 as small as a prism. Sometimes people write like this: 1/3 area base times height. This is the same thing. Multiplying by a third is the same as dividing by 3. So either of these formulas are okay, depending on which you're more comfortable with. And then again, if we have a cone, because remember, a cone is not really a pyramid because it has curved pieces to it, but like a cylinder, it functions the same as a pyramid, just like the cylinder functions the same as a prism. So for a cone, if we want to be more specific, the volume for a cone is pi r squared h, because pi r squared is the area of the base, that's my capital B. H is the height of the cone, and then divided by 3. So once again, for a cone, simply take it as a cylinder and then divide it by 3 at the end. So no different than an average everyday normal pyramid. So let's work out 3 examples here just to show you. One for square, one for triangular, and one for cone. So we'll kind of do one of each type. So for a square base pyramid, so this is a square pyramid because it's 6 by 6 and has a height of 4. So my volume would be area of the base times the height, and then divide by 3. So my height I know is 4 because it just says here 4. That's from top to the bottom. My base, again, area of the base. So my base is a square. So how do I find the area of a square? Well, I do length times width. So 6 times 6, which is 36. So I go back over here. I say, okay, it's going to be 36 times 4 divided by 3. So if we do this real quick, 36 times 4 divided by 3, we get 48. So we get 48. And that'd be cubic kilometers because it is volume still. So again, just like a prism, find the area of the base, times it by the height. Just remember to divide it by 3 at the end. Or again, you can times it by 1/3. So some people do 1/3, so they don't forget, and then times 36 times 4, and they get the same answer. For a triangular pyramid, you have to be kind of careful because remember, there's a base and height for the triangle, and then there's a base and height for the pyramid. So for this triangular pyramid, let's write down the formula. Volume equals base times height divided by 3. The height of the pyramid, so this h here is the height of the pyramid. Well, that's 7 centimeters high. So that'd be 7 centimeters. I'll put just 7 here just to ease my notation. Then capital B is the area of the base. So remember, to find the area of a triangle, the area of a triangle is base of the triangle, so lowercase b this time, because I'm talking about the base measurement, not the area. So the base of the triangle times the height of the triangle, all divided by 2. So let's go ahead and here and do this for this triangle here. So if I look at this bottom triangle, it seems this is the right angle that goes with it right here. So it seems like this line right here is its height, and this line right here is its base. So this would be 4 centimeters high with a 3 centimeter base of the triangle. So 4 times 3. So 4 times 3 is 12, divided by 2 would give me 6. So my volume would be area of the base, which is 6, times the height, which is 7, all divided by 3. So 6 times 7 would be 42. 42 divided by 3 would end up giving me 21, just to make sure that I got that right. Divided by 3. 14 rather, sorry. Good thing I checked. So 14 centimeters cubed. Doom, 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 doom. So once again, it's no different for a triangular pyramid. You just have to kind of denote what are the base and height of the triangle, which in this case would be 4 and 3. So 4 would be the height of my triangle. 3 would be the base of my triangle. So I put BT for base of the triangle and height T for height of the triangle. And this is 7 centimeters. That's just normal, average, everyday H because it's the height of the pyramid. It's the top to the bottom of the pyramid, not just the triangle on the bottom. And then lastly, for a cone, again, same thing as for a cylinder. Treat the base as a circle and do your same thing as you would for any other pyramid. So base height divided by 3. The height of this cone is 16 centimeters, so that's 16. The area of the base. What is a circle? So remember, the area of a circle is pi r squared. So in this case here, since the diameter is 16 all the way across, that means my r is going to be half that, or 8, because I only want to use half the diameter, not the full length. So it'd be pi times 8 squared. And I know that 8 squared is 64. So pi times 64, that would give me 201.06. So 201.06. And then I go back and, again, use my formula. So area of the base, 201.06, times the height, 16, all divided by 3. So 201.06, there we go. So let's go ahead and figure this out because this I cannot do in my head. So 201.06 times 16, all divided by 3, and we get 1072.32. So 1072.32, and this would be centimeters cubed. Now, once again, if they asked you, okay, write this in terms of pi. Well, let's say you got this far and you look back at your problem and you just read the directions and it says write in terms of pi, and you're like, oh my gosh, I don't want to do this entire problem again. What you can do is take your answer, divide it by pi, and you get this, which is not much better because I didn't choose my numbers nicely here, but you get this, and then you can write that as I just lost it here, 341.33. So 341.33 pi centimeters cubed. So this would write it in terms of pi. Now, if they want a fraction, then you'd have to kind of go back and redo the problem. Because if they want a fraction, just to show you that here real quick, what they would have you do is they would have you write like this. Volume equals area of the base, which I'm going to leave it as 64 pi. So area of the base, which is 64 pi, times the height, which is 16, all divided by 3. So in this case, I would do 64 times 16. So 64 times 16, and get 1024. So 1024 pi over 3. And this cannot be reduced because 1024 and 3 cannot be divided by anything. I can't divide them both by 3, I can't divide them both by 2, or we can't divide them both by 5, obviously. So this would be the fractional answer. This would be the exact answer with no rounding. Because again, if you want to check, if I do 1024 and I divide it by 3, I get my answer here. So these are all the same answer. It's just they're written in different ways. This is written as a decimal full through and through. This is written as a decimal for pi, which is still an approximation because I'm rounding the decimal. This will be considered the exact answer because this answer has no rounding involved. This is the entire answer all in one nice package. These two both involve rounding because there were numbers after this 2 here, and there were numbers after that 3 there. So these are both rounded answers, whereas this is an exact answer. So for exact answers, you do have to kind of keep the pi along for the ride and make sure you go all the way through with it there so you can reduce your fraction and leave your answer as a reduced fraction answer so it's a nice exact value. So just again, a little bit note what that happens with circles. Every now and then they might change it up and say write it in terms of pi or write the exact answer. So if they say that, that's what's going on there, right? Just to give you a heads up. So that's it for this video. Again, pyramids are no different than prisms, just divide by 3 at the end. So this entire video can be summed up as the way you find the volume of a pyramid is you treat it like a prism and then divide by 3 at the end. That's the video in a nutshell. Again, please do look back over this here. Maybe kind of rewind the video after a while, go back through, get to this spot, and try the problems on your own first before you watch me do them again. Sometimes if you give your brain a chance to rest for a few hours and come back to it, if you can still do the problem really well, then that means you pretty much got the material. If you're still struggling on it, excuse me, then you can go ahead and email me saying, hey, I really can't get this concept. Here's where I'm messing up. What can I do to help? So hope you enjoyed the video. Have a good, again, day, night, afternoon, midnight, whenever you're watching this video. So.